Intelligence exists as a hypothetical construct, an idea inferred through performance on specific tasks, rather than measured directly like height or weight. To quantify this construct, French psychologist Alfred Binet developed the first widely used standardized test in the early 20th century, originally to identify children who needed additional educational support. Researchers designed tests using factor analysis, grouping items that measure the same ability into distinct clusters. Because success on one test correlates with others, Charles Spearman proposed these abilities reflect a general intelligence factor, or G, rather than a single undifferentiated ability. Quantifying this structure provides a reliable clinical baseline, primarily measuring the output of the mind, but it fails to explain the actual mental processes that produce intelligent behavior. Relying solely on an aggregated general intelligence score obscures the specific cognitive strengths and weaknesses of the individual. Consider two profiles. Person A has standard verbal but elevated numerical ability, averaging a general score of 115. Person B has the exact inverse profile, elevated verbal, standard numerical, also averaging 115. This identical final number masks two entirely different cognitive architectures. Accounts of intelligent behavior require deconstructing the IQ score. Modern psychology has moved toward new models that incorporate cognitive processing, environmental adaptation, and socio-emotional domains. In the mid-20th century, the advent of the computer realigned cognitive psychology. The information processing approach moved away from simple test outputs to examine the internal mechanisms required to encode, store, and retrieve data. The first variable is processing speed, the rate at which a person responds to stimuli. Research suggests a positive relationship between mental speed and performance on academic tasks and standard IQ tests. The second variable is the knowledge base. This focuses on how the volume and organization of information in long-term memory, combined with working memory capacity, influences intellectual functioning. The third variable evaluates the application of mental strategies. This includes the capacity to acquire new problem-solving techniques, such as mnemonic retention and metacognition, the regulation of one's own thinking. Mental speed, an organized knowledge base, and sophisticated cognitive strategies constantly interact to form a functional system for processing information. This framework allows researchers to form specific hypotheses and test these overlapping processes under controlled experimental conditions. While this model details the mechanics of cognition, its internal focus largely ignores how real-world environments and culture shape those mechanisms. Robert Sternberg proposed the triarchic theory of intelligence as an alternative to treating general intelligence as a complete explanation of human behavior. Sternberg defined intelligence as the ability to achieve meaningful goals and succeed within one's specific socio-cultural context through adapting to, selecting, and shaping environments. First is the competential subtheory, or analytical intelligence, which plans and executes tasks. Second is the experiential subtheory, representing creative intelligence applied to novel situations. The third gear completes the system, the contextual subtheory, or practical intelligence needed for the real world. Critics of Sternberg's model point to the difficulty of measurement. Defining and testing creative and practical intelligence as abilities independent from analytical skill remains a persistent challenge for researchers. Sternberg adds necessary ecological validity to the construct by recognizing social context, yet the difficulty of establishing empirical independence brings researchers back to the core challenge of standardized measurement. Howard Gardner challenged the traditional view of a single intelligence, proposing instead that people possess different, relatively independent types of intelligence to varying degrees. Gardner developed this theory by examining the cognitive abilities of average people alongside those with brain damage and special populations, such as prodigies and savants. This grid shows the 8 recognized intelligences. Gardner contrasts traditional linguistic and logical mathematical domains with spatial, musical, bodily kinesthetic, and naturalistic abilities. He also discussed candidates like spiritual and existential intelligence, though only the latter remains a possible candidate rather than a confirmed 9th. A major scientific limitation of this theory is the lack of objective measurement. Gardner has not developed or endorsed widely accepted, standardized techniques for assessing these different kinds of intelligence. Furthermore, research often finds that these supposedly independent intelligences correlate with each other, suggesting Spearman's notion of general intelligence still holds value as a descriptive tool. While Gardner expands our vocabulary for human capability, the absence of standardized measurement tools prevents the theory from replacing traditional psychometric baselines in clinical settings. Emotional intelligence, or EQ, addresses the social and emotional dimensions of behavior that many cognitive models overlook. Goleman's model uses a matrix of 4 domains. The left focuses on the self, self-awareness, recognizing one's emotions, and self-management, controlling impulses. The right column focuses on the social, social awareness, empathizing with others, and relationship management, skills to communicate and resolve conflict. We must distinguish Goleman's mixed model, which includes broad social competencies, from ability models, like the MSCEIT, which treat emotional intelligence strictly as a set of mental abilities. Critics question if this mixed model is truly distinct from general intelligence, personality traits, or learned social skills. Direct comparison between studies is also difficult because many EQ assessment tools rely on subjective self-report questionnaires, which can vary significantly from performance-based measures. Goleman's model has reframed corporate training and classroom curricula to emphasize social-emotional competencies, though empirically separating EQ from basic cognitive intelligence remains a scientific hurdle. To fully understand intelligence, research requires balancing strict scientific testability with the diverse and unpredictable realities of human behavior. On the left, empirical rigor, psychometrics, and information processing provide statistical structure for objective measurement. On the right, contextual validity. Sternberg, Gardner, and Goleman explain how intelligence functions socially. Plotting these reveals a trade-off. Capturing human complexity often sacrifices strict empirical reliability. Traditional psychometrics remains the gold standard for clinical diagnosis and educational baselines because it offers high testability and reliable data. Multidimensional and contextual theories are increasingly favored in corporate leadership and workforce development, where success depends on social and practical adaptation. Intelligence functions as a multifaceted construct, requiring multiple theoretical lenses to capture its true complexity.